Students, next, in continuation with properties of real numbers, so the next definition, let A is real number and epsilon greater than 0, then we set an epsilon A x belongs to real numbers such that absolute value of x minus a less than epsilon is called epsilon neighborhood of the point A. That is, all those x for which x minus a mod is less than epsilon, those x are, the set of those x is known as epsilon neighborhood and is denoted by n epsilon of a. So, on the basis of this, that's the theorem. Theorem number 11. It states that let A belongs to R, that is A is a real number, if X is an element of epsilon neighborhood of A for all epsilon positive, for all epsilon positive, then X is equals to A. Let us see what this theorem states. A is a real number and X belongs to epsilon neighborhood of this A for every epsilon positive. So for each epsilon greater than 0, for each neighborhood of A, this X is in this neighborhood. Then we have to show that X is nothing but the point A. So how to prove it? So in some previous video of my properties of real numbers, by theorem 6, the proof of this theorem is available in some previous video delivered by me. This theorem states that if 0 is less than or equal to A is less than epsilon, for every epsilon positive, then A is equals to 0. Now in this case, X belongs to epsilon neighborhood of A, means X satisfies this inequality, X minus A mod is less than epsilon. So if I replace this A by X minus A, because 0 is, mod is always greater than or equal to 0, so I can replace this A by mod of X minus A. So if X minus A mod is less than epsilon, then mod of X minus A is 0, means X minus A is 0, means X equals to A. So this is the proof. I am writing it again. So take A as X minus A. It implies means or X equals to A. So this is what we have to prove. So that is, if A is a real number and X is element present in every epsilon neighborhood of A where epsilon is positive, then X is equal to A. So Next, there are some exercises depending upon this properties of real numbers. So first exercise, solve for x 1 over x greater than x. That is, we have to find the value of x for which this inequality holds, that is 1 over x is greater than x. So solution, clearly this x cannot be 0 because division by 0 is not allowed. Clearly this is not equal to 0 because 0 does not possess multiplicative inverse. So now case first, by trichotomy property, either x is 0 or x is greater than 0 or x is less than 0. So x is non-zero, it means either x is greater than 0 or x is less than 0. So first x greater than 0. Let's call it inequality. Now 1 over x is greater than x. So if we multiply both sides by x, if we multiply by a positive real number, then inequality does not change. It means x square is less than 1. X square is less than 1. Yes, x square is less than 1. So we have taken x greater than 0. So x square is less than 1 means x square minus 1 is negative, means product of two real numbers is negative. Because x is greater than 0, we have taken by inequality 1 x is greater than 0. It means this x plus 1 is greater than 0. The product of two real numbers is negative, it means one is positive and the other is negative, but this is positive, it implies this must be negative. So by 1 and 2, zero less than x less than 1. So the first step, we get 0 less than x less than 1. Now case 2, if x is negative, call it as 3. So 1 over x. Now if I multiply by a negative real number, then inequality will change. Means 1 is less than x square. This is from case 1. So it means x minus 1 into x plus 1 is greater than 0. Because x is less than 0, it means x minus 1 is less than 0. X is less than 0. So due to 3, so product of two real numbers is positive, it means either both are positive or both are negative. So here this is negative, so this means x plus 1 must be negative. x must be less than minus 1. So x is less than 0 as well as x is less than minus 1. So so by 3 and 4 x is less than minus 1. So from both the cases the solution set is x such that x less than minus 1 or 0 less than x less than 1. Next, exercise 2. If a greater than or equal to 0, b greater than or equal to 0, then square root of ab is less than or equal to a plus b upon 2. That is geometric mean. This under the root of ab is known as geometric mean between a and b, and this is the arithmetic mean between a and b. So we have to show that under root ab is less than or equal to a plus b upon 2. Because square of a real number cannot be negative, so expanding so this is the result, that is under root of ab is less than or equal to a plus b upon 2. Next, exercise 3. Solve for x. Absolute value of x plus 1 is greater than minus 3. Absolute value of x plus 1 is greater than minus 3. So by definition, x plus 1 is always greater than, absolute value of x plus 1 is always greater than or equal to 0. It means always, that is for all x belongs to real. So this inequality is true for every real number. Next, exercise 4. Show that there does not exist any natural number. There does not exist any natural number n such that n less than 1. That is, there does not exist any natural number less than 1. Or in other words, natural numbers start from 1. So how to prove its solution? If possible, let there exist a natural number n less than 1. So it implies minus n is greater than minus 1. If I multiply with minus 1, the inequality will change. Now I take the reciprocal here. Now multiply these two inequalities, I get so this will imply minus 1 into n into 1 by n is means minus 1 is less than minus 1, which is not possible because no real number can be less than itself. It is not possible. So therefore there does not exist n belongs to natural numbers such that n is less than 1. That is, there does not exist any natural number n less than 1. Thank you.